Good morning, class. This is going to be a review of Chapter 8, Lessons 1, and then moving on to Lesson 2, circumference and then area of circles. So let's start on page 613. If you haven't done so already, go ahead and read this paragraph. And then what we'll need to do is we'll need to fill in the vocabulary words. So if you read carefully, you'll see that this first point here is right in the center. So obviously that's going to be the center. It's probably the easiest one to see. And then if you're going to go through only the center to the edge of the circle, that's called the radius. So we're going to call this the radius. It's halfway across. It's smaller than the diameter, and the diameter is twice that size. So that's referring to this entire line here. So this is diameter. There we go. And then moving down toward the bottom, it says describe the relationship between the diameter and the radius of each hoop. So take a second to look at that. And if you didn't already see it, there's actually a connection here where you can see that the diameter is twice the size as the radius for both the child size hula hoop and the adult size hula hoop. So we can say it's 2 times bigger. Then it says at the bottom, describe the relationship between the circumference and the diameter of each hula hoop. So this might be a little bit harder to see, but if you look across, I'll do this one in green. If you look across this way, the diameter to the circumference, we actually have a relationship of pi. Sorry for the crazy cat noise. Of pi times larger. So if you were to do 28 times pi, you would get approximately 88. And then pi being pretty close to 3, you could have estimated that to be, it's about 3 times bigger. Or 40 times pi is also about 126, or 4 times approximately 3 is about that big. So it's pi times bigger. Let's say pi times. Okay. Moving on to the next page. It gives you some examples here that you will need to know, some formulas that will be very important. So if you haven't already, these 2 formulas are going to be incredibly important for this lesson. The diameter is twice the size of the radius. That's what this first one means. And the radius is half of the diameter. Okay, so they're saying the same thing if you think about it. There's just 2 different ways to write the same formula, depending on which one you're trying to find. So let's go down to the bottom to the example problems. And let's try these out. So we'll need to decide which formula we're going to use for the first one. If they give us the diameter of 23 centimeters, what we're going to need to do is we're going to then need to turn around and find the radius. So I want to use the one that finds the radius, and that was, we know that the radius is going to cut the diameter in half. So R is equal to D over 2. So let's do that. Let's take our diameter of 23, divide it by 2, and then your answer for letter A is going to be 11.5 centimeters. I'll do that one in red. 11.5 centimeters. Okay, the second one, letter B, is asking us to find the diameter. Now this one might be a little bit easier for you to remember. If the radius is only 3 inches across from the halfway point to the edge of the circle, how far is the diameter going to be? Well, the diameter, again, is twice as big as the radius. So all you need to do is 2 times 3. Okay. And that's going to get you 6 centimeters for your letter B. Or 6. Go ahead and try the other 2. Pause this video and try the other 2. The next ones we're going to go across to find the circumference of each. Okay, so if you didn't already, you should have seen on the following page, this box here, again, you have two more formulas that are going to be incredibly important. Okay, this circumference is equal to pi times diameter, or the circumference is equal to 2 times pi times the radius. Again, that's because the radius is half the size of the diameter, so you need 2 radii to get as far as the diameter. Okay, so they mean the same thing again, but they're both going to help us calculate the radius. And on the first page, we discovered that circumference is pi times bigger than any diameter. Okay, so this is all going to start to make sense. These formulas don't change. All you have to do is plug in the numbers. Let's go down to the bottom here. Find the circumference of each circle using 22/7 for pi. The reason why we're going to be using this fraction instead of using 3.14 is because 22/7, if you were to find the decimal equivalent, is really close to 3.14, or the approximation of pi. So it works for us if we want to show our work. So let's do this. If we have 70 inches, again, they gave us the diameter. So I want to make sure to clearly label that this is diameter. That means we're going to use the first formula, C equals pi times diameter. And then we're going to plug everything in. Circumference, if I can plug it in. Circumference is equal to, and again, we're going to use 22/7 for pi. And you're going to see something kind of cool happen here. And then diameter is 70. And the nice thing is, these two things are going to cross cancel. 7 and 70 become 1 and 10. 10 times 22 is 220 inches. So, we're going all the way around the circle. The next one gives us the radius, so that means we're going to use the other formula, not pi times d, but 2 pi r. So the circumference is equal to 2 pi r. There we go. And then we're going to, again, use 22/7 for pi. So C is equal to 2 times 22/7, put that in parentheses, and then times 7/8. And I want to cross cancel everything that I can to help myself out right now. I'll even zoom in a little bit so you can see my cross canceling better. So 7 and 7 are going to go away because they're on either side of the fraction bar. I also know that 2 and 8 can cross cancel, so my 8 is going to become a 4, and my 2 is basically going to go away. So all you're going to do is have 22, stop looking at 22/4. And again, we're going to, I actually didn't say this yet, but we're going to want to put this into a mixed number because when we're working with geometric shapes and real life measurements make much more sense if we put them in mixed number form. So this is going to give you 5.5 feet. Okay, if you don't know how I did that, please go look on YouTube how to change improper fractions to mixed numbers. If there are any other practice problems on this page, please pause the video and try them. And last but not least, go ahead and work through your homework from yesterday, numbers 1 through 5. Make sure that anything that you might have learned from this video, you fix what you did, and now I'll give you the answers here. The first answer is 1.5 meters, because you're going from a diameter to a radius, and the radius is going to be smaller, of course. If they give you the radius, the diameter is going to be twice as large, so number 2 is going to be 28. All of these, by the way, need units on them, so if it's in feet, we need to write feet as well. Number 3, it gives us the diameter again, and the radius is smaller, so we know that this is going to get cut in half, so this is a 10-inch radius. Let's keep moving. Find the circumference of each circle. Okay, diameter is given this time, so that means we need to use C equals pi d. Plug in our either use of pi, so we can use our decimal, or we can use our fraction. In this case, 15 isn't compatible with 7, the denominator of 22 over 7. So there's really no purpose to use the fraction this time. I'll use 3.14 times 15. And you can just use your handy calculator, and that's going to be 47.1 meters all the way around the circle. The second one gives us the radius this time. So again, check your formula. It's not going to be the same as the last one. It's going to be c equals 2 pi r. And then we're going to plug in what we know. This time, however, 7 is compatible with the denominator of my other fraction, so I'm going to use 22 over 7 this time. 2 times 22 over 7 times 7, and this is going to do something really cool. The 7's cross cancel, and it's just 2 times 22, so I've got 44 yards, and that's it. I encourage you to try to do this same exact formula using 3.14 and see how close you get to 44 yards. It's going to be very close. You'll get a decimal, and that's true, but the approximation is very close. So go ahead and complete the rest of your homework correcting any mistakes, and I'll be making a second video for lesson 2.